It's working? Maybe not. Oh, it's working. Cool. Yeah, I think please go and grab a beer, and I think we'll get started. Actually, I should have asked Justin. Are you ready? He looks ready. Yeah, but you got a minute to grab a beer and grab a seat, and we'll get started. Okay, so yeah, we're very lucky to have Justin Cormack from Docker this week or month or by month. Yeah, so basically, there's not two talks this time. I was hoping that a rancher would come up because they got in touch, but I think they'll be at the next meetup. So hopefully we'll have a talk from rancher the next time. So that should be quite cool as well. But yeah, I think I'm just going to let Justin take over rather than ramble.
Cheers. Yeah, well, I mean, that's good. If there's not another talk, that means there's plenty of time. You can ask me questions about anything, about Docker or containers or whatever you like. I'm going to talk a bit about Linux Kit, which is the thing I've been working on most recently. But I basically I work at Docker in Cambridge, which is not that far away. Nice train ride. Well, you have to change a piece of bread though, which is a bit annoying. And we have a reasonable size office in Cambridge, so it's as well as in London, but Cambridge is the engineering office in the UK. And I kind of work on a bunch of things. I've been a maintainer on the Docker engine itself for a while now. Can't remember, a year and a half or something. And I've been working on Linux Kit, which I'll talk about. And I work on basically a lot of the open source Docker projects, as well as other miscellaneous things. I worked on Docker for Mac as well a while ago. Don't work on that quite so much anymore, but I can answer questions about that as well. And I do bits of security stuff around Docker as well. So if you ask a really difficult question about AppArmor or something, someone will ask me to answer it. That's kind of what I do. And to give you a bit of background on what the Linux Kit's for and why we did it and where it came from, I think the important thing to kind of ask is, why were containers successful? And I think it was really because that's the way we were thinking about operations at the time a few years ago, and since then, as people have used containers and dev and ops, people were asking these four headings: identifiability, reproducibility, consistency, and agility, from the Wikipedia article on release engineering, but they kind of cover, the way you think about shipping software. What is it I shipped? Is it what I thought I was shipping? Can I ship it again if I need to ship it on another machine? Can I build it again on my machine if I've kind of lost it, or can I build it with a very small change and not accidentally get a few thousand huge changes in it as well? And can I do all this kind of quickly, multiple times a day, ideally, so I can do deployment whenever I want and make lots of changes and be confident that I really know every time I ship some software, I know what's going on. There's no surprise that I'm suddenly shipping something different from what I thought, or when there's bugs, I can identify that they're the bugs that I introduced because of the change I made, rather than something else that happened when I was shipping this software onto the server. And I think that was kind of why containers became successful, because people were already looking for these things and they already had these problems that they were shipping things. It worked on my laptop, but it didn't work in production, kind of thing. The whole idea, people want to get away from that, and do something, you know, it works on my laptop, I test it, ship it into production, it works on production, something then goes wrong, I can reproduce that on my laptop as well by doing the same thing. I can write tests and all the rest of that. And then Docker really brought kind of usability to this. You know, so it wasn't like, I mean, because you could always do these things. You know, it's taken Debian 10 years to do reproducible builds. You know, it was always possible, just really hard. You know, those things. You know, there's a lot of detail involved in these things, and Docker made a lot of this really much easier. There's still, you know, edge cases and things that you have to work on. So everything got much better. But then this quote. This is from 2013. So in the, you know, quite a while ago in kind of terms of the software we're shipping. You know, you log into it, if you're a sysadmin, you log into a server and you don't really know what state it's going to be in. Someone may have, you know, logged into it before and changed some stuff. You know, Puppet's supposed to keep it in the right state or whatever, but we all know that it doesn't fix everything. You know, bit rot is the old term we used to, you know, like to use. You know, digital things don't just stay working. They carry, software breaks over time because, you know, things change. And even earlier than that, Netflix came along with this idea that you should just, you know, the whole beginning of the whole cloud operation stuff. You know what you want your server to do, you build it, deploy it, and you run it. But that's not really been terribly easy to do. This is a diagram of how to make an immutable server using Ansible and Packer from a blog post that came out a few weeks ago. There's a very small link there. I'll post my slides later. But you make an image, you run Packer, you run Ansible, you generate an AMI, and then you start your AMI, and then you run Ansible again on the image locally, and then you format some disk, and eventually you get down to actually running a service. And this, I mean, this is, you know, this is the kind of the best way that you can kind of do what Netscape, as Netflix said. Netscape said in 2011, and it's just really very complicated. You know, using these tools like Ansible that were really designed to help people solve, you know, this problem of, you know, if servers kind of drifting in over time, and the kind of workflow that seems more logical and much simpler is the kind of thing that this is what Linuxkit's really about. I'll show you more in a minute, but it's like, why don't we just have a configuration, build it, boot it, set some runtime config, and run the stuff you want to run. I mean, this is kind of makes more sense to me. So this is kind of what Linuxkit was really designed around. It was just this idea of build something, ship it, and keep it the same, and if you want to change it, ship a new version. And as I said, I used to work on Docker for Mac, and when we started Docker for Mac, we looked at how things were built before, and we looked at boot to Docker and tried to customize it, and I looked at it for a bit, tried to customize it, and thought, this is a load of shit. This is the really horrible system. And so we spent quite a lot of time basically building something that we could ship inside the Mac, inside Docker for Mac, to run Docker. And we came up with Linuxkit, which is basically does that kind of workflow of just build it and you can build your whole server setup in your CI pipeline really quickly, like 20 seconds. Boots really quickly. Doesn't change once you've deployed it. you can redeploy it with automated tooling. You can run Docker or Kubernetes on it, whatever you like, and it's really straightforward, and it can run absolutely everywhere. Obviously, we started with the desktop applications running VMs on a desktop, but obviously then we quickly moved on to running on AWS and Google Cloud, things like that. But you can basically run absolutely anywhere. Embedded machines, we're working on the ARM port with ARM. LCOW is Linux containers on Windows, which is quite fun, which is the new way of running containers natively on Windows desktop and Windows Server, which is Microsoft are just developing right now. And we're using Linux Kit for that. And underneath, it doesn't actually require that you run Docker. It's built around Containerd, which is our an open source project we restarted last year as a embedded way of running containers inside other applications, which is a project we donated to the Cloud Native Computing Foundation that look after Kubernetes and other projects like that. And we did this work with Google and Microsoft and Amazon, who wanted something they could embed the main functionalities of Docker inside other things like Amazon ECS, inside Kubernetes. We want something to do the bit of Docker that runs containers, and it's smaller and lightweight. So this is just released its second alpha version yesterday, and we're using that to build Linux Kit. So it's got a really lightweight thing that runs the services. So I've kind of talked about it, but I'm just going to show you what it's like to run to build a server and boot it. So I'm going to show you the really simplest example, which is just I want to configure a server that just runs Nginx, because that's everyone's always boring example. And this is our kind of hello world example in the Linux Kit repo. And so this is a config file that specifies the whole of a Linux distribution. You don't, like absolutely every single file on the Linux distribution, you don't have to install any, there's no way to install packages later or anything. This is absolutely everything that's installed. And it's designed to be really minimal. It basically has runc and containerd, which are the base components that run containers. And then you specify a bunch of containers you want to run. The important one is Nginx. And it's got a containerd config file that sets up Prometheus. And that's basically it. And I can build this. Oops, I have, yes. Never. And it'll install the kernel and all the programs, processes it, all locally on my Mac. You don't have to have a Linux machine to do any of this. You don't have to have Linux to install Linux, which is great. You can just do it on your desktop. And you can also, as well as building it locally, you can also test it locally to make sure that what you've built is actually working. As you can see, it's a bit quicker than doing a normal Linux install. We can just run it locally when we built, and that boots Linux. And we've booted Linux, which is really nice and quick. And that's running as a VM on the Mac in HyperKit, yeah. And we can check what its IP address is, and we can check that it's actually running Nginx. Welcome to Nginx. But that's obviously, and then we can shut it down, and it's gone away. As I said, so long, thanks for all the fish, because I was testing shutdown support the other day. but we can also just boot this machine. We can build this instead for as a Google Cloud image, which is Google Cloud uses a different image format, so we have to build the disk image for Google Cloud. Those are the exact versions of the packages we're using because we're really, really anal about making sure our builds are reproducible. You could just use latest or leave them blank in theory, but we never push a latest tag to any of our repos because we're totally anal. You can. We have a bunch of labels on the packages which show you which Linux kit git commit it was built from, and then you can see exactly. So if you docker inspect, no, it's the it's actually a git tree commit of the bit under the package in the tree, because so it only changes if you actually change the stuff there, and then you can if you docker inspect one of these things, it should have some. Oh no, that wasn't it. They haven't all because we only introduced. These ones should have because they're new. Yeah, these have got revision and source, so you can see that's the git commit it was built from. Sorry? Yes, yes, they kind of got merged into the OCI image spec in the end, so we used those ones. We were going to use the other, and then I can push this image I built to GCP. Just tell it a bucket I want to push it to. I tend to use GCP because actually it's really nice and quick, so it's good for demos. AWS is tends to be a bit slower, and so that's uploading the image I just built to GCP, and then creating to the bucket, and then it's creating a bootable image from that using the API. Again, all from my laptop. Generally, I mean, it depends what you build on them, but I mean, this is 68 meg. And then I can just you can obviously run it just directly from the console, but we also the tool will the LearnSkit tool will also just let you run it for test purposes directly, and it gives you an attachment. It attaches to the console over SSH, so you can actually in a minute when it's booted, it should. Well, it's containerd, so it's the cut down one. Now this is booting on GCP, and we're on the GCP console. If you look at what's running, you can see there is containerd is running, and then it's running containerd shim, which is what containerd runs there, and then it's running. I'm not sure if we've got PS3 installed on here. Yeah, so it's just basically just running it through containerd. So we actually run Docker from containerd at the moment, because at the moment Docker's using the old version of containerd. When it's using the new version of containerd, we'll just use the one containerd, because now containerd has namespacing, so it can run multiple different applications at the same time. So they'll all share the same instance of containerd. this image obviously isn't running Docker, it's just running Nginx because it was my absolutely minimal example. So it's, sorry? No, the Linux kernel's not very big. The kernel's about, I think it's actually, is the kernel on the root image here? No. The kernel is about the Linux kernel is about 7 meg, and then it depends. There's some modules. Yes, the joys of this is a. There's apparently 40 meg of kernel modules in there, so which is I'm slightly surprised by that. But yeah, it's something around that. The kernel's not that big. You can cut it out. We have various ones. The image we have for the Linux containers on Windows is the whole thing is about I think about 15 meg or something like that, which was, or maybe even less than that. It was slightly smaller than Microsoft's one that they produced for testing.
So once you have the sort of working on the map, do you have to do anything to get the GCP image, or basically get that for free?
You basically the Linux kit command basically, sorry, the Moby command can actually build any of these formats here. So it can build, so it can build it can build VHDs and QCOWs and basically a whole load of stuff. ISOs, so basically anything that a computer might need to boot. GCP images are actually disk images tarred up and compressed for some random reason. So everyone has their own different formats. So we just support and various EFI ones and various different kinds of VHDs for various other platforms. So you have to build each one separately, but they're generally quite, it's generally you only want 2 or 3 different ones maybe, and you can build them all. Actually, you can build multiple ones at the same time, so you can just run it and say I want 3 different ones. Sorry? So the AMIs are. We tried various things. I actually can't remember what we're doing at the moment. Someone else wrote that code. Originally, when I wrote the original version, we were doing the thing of you had to boot up a machine and save the disk image. But I believe that we managed to do it without doing that, but not using the import thing, because that never works. But I'd have to look at. Someone else had some idea and one day and came out and wrote it. So it's really annoying that Amazon make it really difficult to just. That's the nice thing. I did the Google one first because, because I did that for the Google Cloud Docker for Google Cloud Edition. I thought I'd give a Google Cloud a go because I hadn't used it for a few years, and I got it all working in an afternoon because it was just so easy and also really quick, so you could iterate, and you get a serial console you can log in, which none of the other clouds give you. So when something goes wrong because you forgot to build something into your image, you can actually log in and check, which is so nice. So we have lots of examples which have things like, here's the one with Docker built in, which just has which does things like setting up. We have basically containers that do things like formatting and mounting disks, which you can configure things like which file system you want to format, and So I can build I can build these examples, and then you can run them with a disk, and it'll format the disk if it's not formatted and things like that. Yeah, basically there's a bunch of stuff that gets done sequentially on boot. There's a bunch of services that are the things you want to run once those are finished, and then there's a bunch of things that will run on a clean shutdown, but not if it's not a clean shutdown, obviously, because if you pull the plug, you can never guarantee that. So, and that's generally worked quite well. We're working on some more complicated configuration if you've got services that just want to talk to each other securely and with sockets and things like that, so to make it easier. But generally, because the original model that we built this for was running Docker, so you just wanted enough services to bring Docker up, and then you'd run dynamic stuff on Docker. But now a lot of people actually want to do things like add extra management services and stuff to configure things, and we're working on the Kubernetes support, which we demoed a really hacky demo of at DockerCon, but there's a load of stuff you need to run Kubernetes, and it actually, and on the demo, they're running under Docker, but it doesn't really make much sense. They should be running system services. So looking at fixing that up. So yeah, so it's kind of a mix of how you want to do things. But we're trying not to make it a horrible, complicated dependency management system, because that would be kind of horrible. It's not systemd. And you know, it's not. I mean, in theory, you could run systemd, but
So you're basically saying Docker's replacing systemd as well.
no, because it's not doing all the complicated stuff. It doesn't have anything built in. It just, all the containers are things you want to run, and we really just provide a minimal set that you can use if you want to, or not use, but it's not going to force you. If you don't put something in your config file, it won't run.
Well,
it won't exist.
I guess what I'm saying is container is taking care of making sure the services are running and
Yeah.
fail.
Yeah, well, at the moment we don't. Yeah, we will add that support. System services shouldn't fail, but yeah, we will deal with restart. People have asked us to do restart, but I mean, I think you should, if your services start failing, sometimes the right thing to do is just redeploy the machine at that point. It all depends what fails, but quite often it's failing for a good reason, like the disk's full, or there's well, memory. They're containers, so you should be able to configure memory usage and things. But yeah, I mean, basically, yeah, I mean, mostly, like with the things like the, I mean, with things like Nginx or something, if it just runs as a service, you can just use the, this is just the Nginx. The Nginx example was just using Nginx Alpine from Docker Hub, unchanged. Added a few capabilities because Linuxkit doesn't add any default capabilities, unlike Docker. So you have to do that a bit. And then that's it. It's just straightforward. It's just the image from Hub. It runs just like it would under Docker. So the only complicated things are if you want to share, I mean, if something like syslog wants to share some files from other bits, so you need to add some bind mounts and things like that. But generally, if you've got it running in container and it works, you can just include it. It's really straightforward. The reason that there's no config in all these containers generally, and they just look really straightforward, is that we actually add all the config as as labels on the containers. So if you look at if you look at one of these, you'll see that there's a a label here which tells it that it needs bind mounts of var, etc., and it needs these capabilities. So you don't have to put them in the config file because you basically pretty much always need them. So if you add those labels to your image, you can see that if you look at the Docker files we build everything from, so DHCP, the Docker file there, it's just a nested build that just adds DHCP in, and anything else is from scratch, and then adds the labels to tell it what bind mounts and things it needs to run as a Linux Kit container. So it's relatively straightforward to basically add anything you want. I mean, we're happy to take pull requests for stuff that it makes sense to have, that lots of people want to use. I mean, we have a bunch. This is all the kind of stuff that we've got at the moment. Some of them are specific to Docker for Mac, because we've got all the examples of pretty much how to build Docker for Mac is in the repo. But most of them are general time synchronization, NTP. And there's a bunch of stuff around logging. We're working on, we've got a project around logging to do remote logging and things like that for logging to AWS and things like that, because we need that internally for all the for Docker for AWS, things like that. So we're going to build in a modular logging facility for controlling where your logs go. So you can, so we should have a syslog type stuff built in soon anyway. But it shouldn't be too much work. Yeah, you can. It runs on, as long as you've got Windows 10, you can run it under Hyper-V. Well, it runs. I mean, it runs as a VM. You can run it. You can build locally. You can run locally. I mean, it just makes the development experience straightforward. It's not really a security issue. It's just a nicer development experience. You can run things locally. I mean, almost all the development work we did on the Mac because it's just really easy. But yeah, we're doing all the work for the Linux container stuff now on Windows. And you need. Some of it needs Docker to build, some of it doesn't. We're trying to make it all self-contained, but at the moment you need to have Docker for Windows, or Docker for Mac, or Docker installed, and that's basically the only requirement. Everything else just works on any platform, and that's always been the idea. That and we've done quite a lot of Windows integration work with Microsoft in terms of Azure and running locally on Windows as well. Yeah. Yeah, so we've got a package called metadata that tries to abstract the common forms of kind of boot time metadata you get from most providers, and it's relatively flexible, and then it produces them as files that you can then bind mount into the containers. We don't have a way of saying as environment variables directly yet, but it will be fairly easy to add that as well. But so it supports AWS, Google, Azure, a couple of other cloud providers, and and things that bind it, that make virtual CD drives or real CD drives, and you can add other providers. It's quite straightforward. Sorry? Actually, weirdly, we have got OpenStack support since about 3 hours ago. So you can now, yeah, you can push images to OpenStack to boot. So in yeah. Is, yes, we have actually have VMware support as well. Both locally on the desktop and vCenter as well. Where were we? Maybe I haven't. Hold on. Where's? Oh, sorry, I haven't merged it yet. Yeah, that's. Oh, look, okay. Yeah, we have OpenStack support now. And if you check the documentation, here's the tested versions and image types for OpenStack. Yeah, Dan, who some of you know, has done both the OpenStack support today and also a lot of the vCenter support as well, and VMware support. As well as that, we also have, yeah, you can also run on bare metal as well as if you, we actually have a lot of people who are interested in running on bare metal because then you don't have to bother with the hypervisor stuff at all. And there's lots of really nice management software for bare metal nowadays where you can, buy something that has an API where you can configure Pixie Boot and stuff like that, and configure what you want to run. And so we have both Dell and HP and or Packet.net who do that both as a cloud service and will also do it on-prem or as a service for you as well. So you can basically manage complete bare metal solutions, not bother install a hypervisor at all. You can run a hypervisor on LinuxKit if you want. So you can run KVM, has KVM support now. If you want to run VMs on top of it, or you can just run great big machines and run lots of containers on them. Yeah, we have the common ones for modern hardware installed. It's kind of, if anyone complains that we don't have something, I mean, we basically have the. Unfortunately, there's fewer drivers than there used to be because all the. I mean, if you're going to run hardware, you're going to have 10 gig Ethernet and things like that, and there aren't that many drivers anymore. It's not like the old days when there were 3,000 10 meg Ethernet drivers, and there's now 5 or 6 or 7. So. Hardware support actually is a bit simpler than it used to be in the bad old days. We don't have much support for kind of desktop, laptop class hardware, although people have booted, but there's no wireless support, for example. I mean, you could add it, but I'm sure someone will ask for it at some point. But generally, we're mostly interested in servers. And if you're running hardware, you're running 10 gig or 40 gig or 100 gig Ethernet, and that's. Yeah, actually, well, ARM are doing the ARM support at the moment, and yeah, there'll be a bunch of drivers for that. I have no idea what they put in their kernel at the moment, but we do have people who want to run it on Raspberry Pi. So, no doubt, once that's all merged, it's in process, then that will suddenly happen. I just put in a bit of a note about kernels because another of the reasons for doing this is that basically, as I'm a maintainer on Docker, people complain when it doesn't work for them, and one of the things they complain about is my kernel keeps crashing. And there was a recent article where someone was saying, my kernel crashes 100 times a day with running Docker. I hate it. And we want to address some of these issues. And the main problem is that people are not running modern kernels; they're running really old kernels. Those kernels is one of the biggest open source projects. Last week they merged only 11,258 change sets for 4.13 is less than 4.12. They merge them in phases, so there's usually a few days when you have to submit your patches for the next release. And we only basically support upstream modern recent kernels with a very few patches that we maintain, which are mostly around Windows support that we're working with Microsoft on upstreaming and fixing. And we would really rather people run containers on a modern upstream kernel because it works and because we can fix bugs. And basically, if you have a problem with a container and something crashes, some networking thing, and you get a kernel panic, if you can replicate it on Linux kit, we will fix the bug. That's basically our because we can't fix it if you on your Ubuntu system. You can go and complain to Ubuntu, and they probably won't fix it for you. But this is we want to actually fix the problems people are actually having in production, and it's really hard if we can't reproduce them and things like that. So anything that we can reproduce, we will fix. I mean, people are running these horrible kernels, and the distros tend to, a lot of them, if you install the long-term support releases, you'll be running something that's originally 4 years old with some bits from other pieces, which are known in the trade as Franken kernels. They're very hard to fix the bugs. They don't even produce. Red Hat don't even produce actual broken down patches for them anymore. They just have a giant patch of the whole difference between their kernel and the other one. And it's really hard for anyone to work out what's going on there other than them. So you can either pay them lots of money and hope that they'll fix it, or use an upstream kernel, and you can actually submit issues to the kernel mailing list, and people will look at them if they can reproduce them. And new kernels are more fun and more secure and more useful. One of the things we're doing with LinuxKit is helping new kernel projects basically get more use. So today we merged support for WireGuard, which is a really, really nice modern VPN toolkit in the kernel, which is also ideal for running with containers. Basically, if you want two services to communicate securely with each other, you can use WireGuard to do this. It's under 4,000 lines of code compared to things like IPsec and so on, which are like hundreds and hundreds of thousands of lines of code. Just uses simple modern crypto. Just works. You just get a nice network interface that your program can talk to, which is automatically encrypted and does everything for you, and it's really, really nice. There's a talk from yesterday that's recorded that the link's in the LinuxKit repo for, which is from the author, which is really nice, talking about the internals of it and how it works. And so we're going to be spending time working out how to do modern container networking over that so that you can use it really easily, and then eventually it'll get upstreamed into Docker, hopefully, and other container systems. But these things are, you can only try them out if you're running new stuff, and your kernel's not going to crash 100 times a day. And if it does crash, there's some chance that someone will care enough about it to fix it. And actually, it kind of makes things fun. It's, I've boot up, we run our CI system for LinuxKit. Every time you do a PR, it boots maybe, I don't know, I was going to try and count it, it's maybe 100 or so Linuxes. And I've probably built, more Linuxes since I started on this project than, well, probably thousands of times more than I've ever actually installed by hand. And it just feels very tedious going along and, remembering to install all the bits of Ubuntu each time you install it because it hasn't got the things you wanted installed. It's like, it's actually just nice to just have something that every time you install it, it just does exactly what you want. And so yeah, that's kind of, it kind of extends what we did with containers all the way down to the bottom of the stack, which I think is sort of quite fun, really. And it takes bits of container technology and repurposes them for other use cases, which is also something that's really interesting. I think that there's a load more people interested now in things like using containers in embedded devices, and this is kind of very similar to that, and we're interested in supporting those kinds of use cases and things like that. And containers are just becoming a way, it's just, containers are, as I said at the beginning, a kind of modern software deployment. That's the way that we wanted to do things, and that's the way you want to do things everywhere, not just for deploying your web application, but also deploying your server, deploying your light bulbs, your, all the computers that are around. And I think that's really exciting because we can do software development properly and securely and nicely and manageably and understandably, and makes in a way that we can actually build lots of cool stuff. Well, I hope to take questions on absolutely anything, not just any containery stuff, whatever. So exactly reproducible, you mean? Almost. We're nearly there. They are. We're very careful about this, and we have been for a long time. So, and we do things in a way that most people building stuff in containers don't go as far as. So, for example, basically none of our builds use the network at build time at all. So we use Alpine as the base for almost everything we do. Some of it's just Go code from scratch, but we build it with Alpine. But we actually have an Alpine package that has the whole of the package repository that you normally fetch with apt-get over the network built in, so that we get the same packages every time. So the builds are not bit for bit reproducible because of things like timestamps on things. I have done a little bit of prototype work on getting Docker builds to fix those issues, and I know what the problems are with the timestampy stuff, and there's a lot of work Debian's done, which I kind of joked about it taking 10 years, but it's really hard. So we should be able to do bit for bit soon, and it's definitely an aim. But at the moment, I think that the actual binaries are probably, unless there's any randomness in the actual compilers, which in general I think for Go, which most of it's Go and C, there generally isn't, then they should be, the actual binaries should be reproducible, but probably the timestamps of the files and things probably aren't. The actual disk images are, again, probably there's probably timestamps in loads of places because I haven't tried to get rid of them yet. But yeah, we definitely want to do that, and we're getting there.
So what about unikernels? How far is this? Is this sort of every man is using?
Some people have said that it's got some similarities, but yeah, sorry, I've worked on unikernels, but yeah, it's I think there's some similarities in that, but mainly because unikernels do the immutability thing. I mean, I think it's I think there's some similarities because they're kind of small and compact and immutable, but I wouldn't say it's quite there. We're trying to use we've got some projects to use a lot of the unikernel stuff for making system services that are, because at the moment we're mainly using the traditional system services, like the traditional ones written in C. We're rewriting secure ones using type-safe languages and using some of the unikernel technology and allowing you to run them inside VMs as unikernels, as for your actual system services, you're running things like that. So that's on its way. But I think most of the similarities come from the fact that it's just immutability and stuff, which is something that mainly comes from doing software properly.
I mean, I assume I can take my own kernel, because that's binary built into the rather than take one that you use.
Yeah.
Actually, that's one question I had. I thought you're using all the Alpine stuff. I thought you were going to try and get PAX stuff integrated with the kernel as well. Is that right?
Well, PAX. Well, yeah, we were, and then they decided that they were not going to release the source anymore. So it's a bit the GRSec stuff. They're not releasing proper source code anymore. It's really difficult. So we are currently working with the kernel hardening project, which is trying to upstream some of that stuff, but we're not directly using PAX at the moment. Indeed, you would have thought. Yes, they've basically got this kind of workaround from the GPL that they will only sell it to people who will agree that they won't. Well, if they do release the source, they won't ever sell them any updates. So no one releases the source and they don't. So it's a bit weird. We tried very hard to work with them. They are difficult, but I mean, yeah, I mean, they kind of prefer their current business model to other ones. It seems we try. I hope so. I think Packers. Packers are. When I started doing this a few years ago, I looked at Packer because it's the kind of market leader in this space. But the thing that really kind of made it, there's two problems I have with Packer really. One is that you have to run it on a booted machine, whereas we tried really hard with NSKit to make sure that you can build everything locally before you boot the machine. So the process is kind of rather than booting the machine, running Packer, installing some stuff, snapshotting it, and then booting it again when you want to run it, you just the way the actual build process with NSKit goes is first of all we basically build a tarball of the root, and then we basically convert that to whatever image format you want, so in a file system or something, which might involve booting a VM in some cases, or it might not, in order to build an X4 file system if you have to, but we're trying to avoid that if possible. But all you're doing is just converting a tarball into a file system at that point. So it's much slower from that point of view because you have to basically do everything twice. And then the other thing is that then you still need a configuration tool to work out how to install the machine, and with Packer, so you still have to have all the things that you have to have for a kind of non-immutable machine. You have to have a package manager so you can install packages. you have to have something that says what you want to install, has to configure all the bits and pieces of the, so normally people would run something like Ansible or something to do that, and then so then you have to pack it. It all gets rather, it's basically reusing a bunch of infrastructure we had from the old model of how you install machines, and in this case it's just like, I want my machine to look like this, make it, and it just is, as you can see, it's really quick, and so it's just much more direct and straightforward. Of like you guarantee that it's exactly what you specified, and the conversion process is really simple. The code's really small. It's basically a bunch of code to manipulate tables of various sorts and combine them, and read through config files that say how to combine them, and then generate some OCI specs that get fed to containerd. And it's you can understand the whole process really straightforward, and you know that how it's gonna work and exactly what you're gonna get. Like every there's literally nothing that's not in the config file that you get. It makes no assumptions whatsoever. The stuff we did for the lcal stuff for Windows doesn't even use most the standard stuff for LinuxKit really. It has its own custom in it. It only runs one program. It doesn't, it's really, really cut down, and that's fine. Or you can build something more complicated. So it's really, yeah. I mean, I tried to use Packer and decided it was too indirect and complicated, and so yeah, I hope it does. Yeah, so most people use DHCP to configure IP addresses, but other people use config metadata to configure. So, for example, IBM are working on support for Bluemix, and they configure all their IP address information from metadata they pass into the machine. So it gets given a specific IP and gateway and everything, and that's all in a config file they pass in as a virtual CD-ROM drive to the VM, and that I think we use a weird hybrid mechanism on Windows for the lcal ones and things like that. So most of the examples we have use DHCP just because that works in most situations, but you don't have to. Just remove the DHCP thing and put in an alternative config. Again, you have to configure something. At the moment, we don't have anything as standard to configure the firewalling because originally it was set up we were mainly using it for Docker, where Docker can manage its IP tables, and managing them yourself is not very helpful. But we have people who want to do firewalling stuff, and so we will definitely have an easy firewalling package set up. But I mean, you can basically just include an IP tables config file and run an Alpine container that configures that really trivially. That's the easiest way of doing anything like that. You just include an Alpine container, and then you say, as it's the command you want to run, you just say run this script that sets up IP tables or something like that.
Okay, well, let's have one last question, and then I think we can. Well, people can easily ask questions later, but I think there's a few drinks left. We're going to keep drinks and come and ask different questions. But yeah, go on, John. What's your last question?
So you built your image, you built your particular image of your into it. At some point, you're going to want to rebuild that to get this.
Yeah. Yeah. So, um, yeah, obviously it's really important to be able to upgrade things because the last thing you want to do is just have a machine that sits there for all eternity. Linuxkit itself doesn't care. It doesn't. It's at the end we're just generating AMIs or whatever, and it's It's designed that you use some other tooling to manage the life cycle of those machines. So internally we use a mixture of things. So you can use some platform-specific stuff, say on Amazon or something, or we have another project called InfraKit that is designed as a kind of portable way of doing this across lots of platforms, and we're doing more and more integration with Linuxkit so that you can. It's basically designed to give a uniform experience of the kind of things that the cloud APIs give you, but you can run it on any platform or on bare metal and so on. So it can do things like rolling upgrades for you. You just give it a new version and it'll do a gradual rolling update, make sure they're all healthy before it upgrades. And it's designed to be programmable, and it can also do things like reattach disk volumes to machines. So we don't store any state at all in the actual root file system, but you can attach a volume, format it, and then attach data to it. But if you want to upgrade the machine, you can throw away the machine that's running it and then reattach the disk with the persistent data onto a new rebooted one. So, and InfraKit's really good at managing that type of stuff. But anything you want to, like Terraform or whatever, you can also use directly if you want to manage it through that. The aim is to just, the Linuxkit tooling produces the images, and then you have another set of, and we have the commands to boot it, but those are really meant for just interactive use as a development tool, we're not in the business of making production tools for doing those things. But yeah, InfraKit's really cool, and has some integrated support for doing things like building custom Linuxkit images and things, and we're going to do a whole lot more integration there. But yeah, anything you like, really. But yeah, you definitely need something. But if you've got something already that works for you, it should work with that.
Right, can we thank Justin once more? Okay, that was great. I think we've got a few beers left, maybe. But after that, we'll probably head up to the, what's it called? Blue Blazer. There we go, thank you. Yeah, so go and grab a drink, and like a few minutes we'll head up to Blue Blazer for anyone that's interested. Oh yeah, I am actually doing a webinar tomorrow on Linux security if anybody is interested. You can find it, details on my Twitter. Just getting a plug in there. Okay, yeah.
You know a lot about that.
All right, thank you all very much for coming. Pardon? No, not about, well, no, not about firewalls.